I'm sorry?
I said, how's the new year treating you?
Oh, it's been treating me pretty good. How about you?
Good. Yeah. Getting back into tutoring. Most students take they take 3 or 4 weeks off at the Christmas break, so I get quite a vacation over.
Yeah, that's nice.
Yeah. So what do we got tonight? What kind of math are we doing this semester?
Well, I actually, I made a switch in my math classes
Okay.
from the first semester to my second semester.
Uh-huh.
So I'm still in Algebra 2,
Okay.
but I'm in what my school calls Algebra 2S, which is like the slower paced version, I guess.
Okay.
So the kind of interesting part is that my new class was not even more close to caught up to my old class.
Yeah.
So I have my first test tomorrow
Uh-huh.
in my new class, and we are back to like factoring and completing the square,
Huh?
and it's just been so long since I've done that. So
Amazing. I've seen this phenomenon a few times before, and it's always that way. Whenever somebody goes from like an honors class to a regular class, they've done everything, so they're really good at it at first.
yeah,
And yeah, for a while you'll have quite an advantage.
yeah, because yeah, like my notes in my old class are so much far ahead than my new class,
Mm-hmm.
but since I was so far ahead, I've just kind of forgotten how to do some of this
Okay.
material, even though we've
Well,
covered it a little bit.
it's pretty easy to, if you take a month off of doing something, anything, it's amazing how tough it is to get back in the groove.
Yeah.
Probably like that with tennis. You've probably never taken a month off in tennis, have you?
Oh, if you do that, you're not very good the next time you play.
No, oddly enough, I was having dinner with my cousin the other night, and you could probably relate to him. He was the #1 tennis player in the state of Colorado when he was 18 in high school.
Wow.
And he went on and played tennis at CU, and he kind of had an injury that destroyed his tennis career, but he was telling me his lifestyle back then, and it sounded very similar to what you do. He was driving all over the country playing in these tournaments, and his mother,
That's
my
awesome.
aunt, was driving him to an awful lot of them. But it can be pretty lonely also, because he went to a lot of them by himself.
Yeah, some of the times that happens, but luckily my parents go to a lot of them with
Well,
me.
that's
So
nice. Yeah,
that's
that's got to make it nice.
yeah.
Okay.
Well,
Well, what do you
all right.
cover tonight? You have some problems you want to do?
I was actually just searching for my review packet that I've been working on the past few days,
Okay.
and I have no idea where it is, even though I had it just a few seconds ago. It's funny how that always happens.
Mm-hmm.
But mainly, the main thing
Completing
that
square, right?
I'd like to go over is completing the square, and then factoring. Here,
I
found
can
it.
make some problems up for completing the square.
Okay.
Okay? There's two kinds of completing the squares. Just like factoring. There's two levels of difficulty in factoring. Well, let's talk about factoring first.
Okay.
This is the easy level of factoring because the coefficient of the x squared term is 1. Right?
Right.
So the first step is separating the x's. That's the only way that can be done. The next step is determining the signs. They're opposite. Plus minus is the same as minus plus, so I can go ahead and write plus minus. And the third step says factors of 2 that subtract to the coefficient of the middle term without its sign. So I need factors of 2 that subtract to 1. Well, that's 2 and 1. Bigger of those factors goes with the sign of the middle term, so the 2 goes there and the 1 goes there. Okay? So those kind of factoring problems always come down to those 3 rules. Sometimes it's factors of this that add. If that's a plus sign, they would have to add to the coefficient on the middle term. But these level of factoring problems are pretty easy, and I suspect you can do most anything that I would throw at you.
I would hope so. That one was pretty simple.
It gets more difficult if you have a coefficient in front of the x squared term, because now the number of possibilities goes up huge. In other words, I have to break up the 6x squared. I could do it with 3x and 2x, but it might be 6x and 1x. And then I got to break up the factors of 12, and they could be 12 and 1, 6 and 2, 4 and 3. So also I know my signs are different, but it could be plus minus or minus plus. So just by putting a coefficient in front of the x squared term increases the degree of difficulty of factoring considerably. And it becomes a lot of trial and error. Same thing. Yeah. Completing the square isn't quite as more difficult, but the same thing I'm completing the square. If I have a simple one like this, let's take one where it's like that. Okay. All right. We'll set it equal to 0. In other words, we'll solve this equation. Now, you can't factor that. If we try to factor that, I'd be looking for factors of 10 that subtract to the number 4. And there aren't any. Yeah. Okay? So I've got 2 choices on how to solve this. I can plug everything into the quadratic formula, which most people are hesitant to do. But I can also solve it by completing the square. And the way I complete the square is I want to isolate the terms that have x in it. I want to take everything else and set it aside for the moment. So the first step I'm going to do is move that 10 to the other side of the equation. Haven't changed anything yet. Now I'm going to put parentheses around that and complete the square inside the parentheses. What do I how do I complete the square? Remember?
Yeah, you're going to take half of the half of 4 and then square it. So you're going to get
And you're always going to be adding, never subtracting when you're completing the square. So I'm adding 4. Since I add 4 to the left side of the equation, I got to add 4 to the right side of the equation. Now, how can I rewrite the left side of the equation? In other words, the reason I completed the square was so I would be able to write it as a linear factor squared. What is that linear factor going to be? X what?
X minus 2 squared.
Exactly. In other words, it's always x plus or minus whatever half of that middle term was. And it's plus or minus depending on whether that's a plus or minus. In this case, that's a minus, so this is a minus. Well, this is all equal to 14. Now, I can solve this for x, because I have it in a format where I can now take the square root of both sides.
Right.
What do I get when I take the square root of both sides?
You get x minus 2 equals Plus or minus the square root of 14.
Perfect. You remembered the plus or minus. 95%
Yeah,
of my students forget that.
yeah, that's the tricky
It
part.
is.
I forget that on tests, and then I have to then I remember right at the end.
Well, let me give you a little bit of help as to how you can always remember it. When you're solving a quadratic, you expect two solutions. Always. Occasionally, both of those solutions will be the same, but not very often. Most of the time, you get two solutions, and that's what we got here only because of the plus or minus. Notice that if I forgot the plus or minus, the solution would be 2 plus square root of 14. But there's another solution. There's 2 minus the square root of 14, which is a different number altogether. So those are my two solutions right there. And if you're solving this expecting to get two solutions, you'll never forget that plus or minus. It's only if you forget it, and then you end up with only one solution.
All right.
Okay, that's...
Okay, yeah, this is, it's coming back.
Okay, this, like factoring, is fairly easy when the coefficient of x squared is 1. Okay, let's do a harder one. Let me put a coefficient in front of that thing of 3. Yeah, we'll make it a little easier than that. We'll make it 2. And we'll make this number 9. Okay?
All right.
And again, if I were to go to try to factor this, I don't believe that it factors. No, there's 3 times that is 6. 1 times that is 4. No, there's no factoring this. So, again, we have two choices. We can substitute it into the quadratic formula. And notice that quadratic formula, let's just talk about that for a second. In other words, x equals minus b, there's your plus or minus, square root of b squared minus 4ac all over 2a. This always is going to give you two solutions, unless this quantity is 0 precisely. Then you'll only have one solution. But in every other case, this plus or minus means you have two different solutions. What is A, B, and C here?
A is 2.
Okay.
B is -4, and C is -9.
Okay. So you could do it by plugging it into the quadratic without too much difficulty, but let's do it by completing the square.
Okay.
This is slightly harder than the other one, only because of one thing. We still want to isolate the x squared and the x, so my first step would be to move the 9 to the other side. Now, we cannot complete the square until or unless the coefficient on the x squared is 1. Has to be 1.
All right.
So what's my first step?
You're going to have to divide by 2.
Factor out a 2.
Yeah.
And the trick here is to make sure you never change anything. At this point, I have not changed anything. It's identical to the initial quadratic that I started with. And that's the way you want to do these, is every level, check and make sure that it hasn't changed. And it's a good way to avoid mistakes. Now, complete the square just inside the parentheses.
We're going to add 1.
How much do I have to add to the right side of the equation?
You're going to have to add 2, though.
Yeah. Very good. It is coming back, I can see. So now I can rewrite the left side as how?
As 2 parentheses x minus 1 squared equals 11.
Okay, next up.
Would you divide the 2?
Yep. In other words, we're trying
okay.
to isolate this thing so that I can take the square root of both sides to solve it. And
Gotcha.
that won't do any good until I get rid of that 2. So now I got x minus 1 squared equals 11 halves. Now I can take the square root of both sides. And add 1. Is that a satisfactory answer?
I think so.
Actually not.
Oh.
The reason is this part here. That's the same as having an irrational number in the denominator, because what that's equal to is the square root of 11 over the square root of 2.
Oh, so that's not going to work.
Well, it's fine mathematically. In other words, that's a perfectly fine mathematical answer, but mathematicians don't like having irrational numbers in the denominator. They consider that not the format that you want. So we have to rationalize that. Rationalize an irrational denominator by multiplying top and bottom by that. In other words, all I'm doing is multiplying that fraction by the number 1, which you can always do without changing any value. And what it becomes now is root 22 over 2, and I have a rational denominator. So this is the way you would want to convert that. So instead of writing the final answer like that, I would write it as square root of 22 over 2. And now I don't have any irrational denominators anywhere.
Got it.
Okay. And that's something that is not obvious when you first look at it. It's something you have to be a little careful with. If I had, say, the square root of 3/4, well, that's the square root of 3 over the square root of 4, which just means square root of 3 over 2.
Over 2.
Okay? But if I had the square root of 4/3, whole different problem, because now that's 2 over the square root of 3. I got an irrational denominator. I got to rationalize.
So then you got to multiply the top and the bottom by root 3.
Exactly. And then that makes the top 2 root 3 over 3. So that becomes this. A lot of times after you rationalize something, it looks completely different.
Yeah.
And it's hardly recognizable. If I started with this and I said, give me the same answer with an irrational denominator, I'm not sure I would know how to do it, because it just doesn't look anywhere like it. I mean, it doesn't look anything like it. So it would be hard to go in reverse.
Okay, yeah, this is all making sense again.
Yeah, completing the square is always that process. Now, let's go back and make it a little harder still by not making everything such a nice round number. In other words, let's make that a 3. Okay, still can't factor it. I still can't take out a greatest common factor.
Nope.
But I can complete the square. Completing the square will always give you the answer to the equation, just like the quadratic formula always gives you an answer. And they'll always give you the same answer. It's just there are other kind of problems where you need to be able to complete the square, and that's the only way you can solve the problem. So that's why they really spend so much time teaching you how to complete the square. So what would the next line here be?
The next line is going to be, you could do...
You may not actually get anything this difficult in your class, but...
Yeah, so far we haven't seen anything.
That's all right. Let's do it, because if you know how to do this one, you'll know how to do any one you come across.
All right. So, are we going to pull out a 2 still?
What's left?
X squared minus 3 over 2x.
Okay.
All right. Equals 9.
Okay. Next step.
Then, next step is going to be half of 3 over 2. So that's, is that 3/4?
Correct. And then square that.
Square that 9/16.
Okay. How much did I add?
Oh, that's interesting.
How much did I add to the left side of the equation?
2 times 9/16. So
18/16.
18/16.
So add 18/16 to the right side. Now everything's balanced. Now how can I write this?
You can write it as 2 parentheses x minus 3/4 squared equals
That's 10 and an eighth.
10 and an eighth.
Okay. Now the rest of it is just the same way as you'd solve any of it. In other words, the fact that we have fractions doesn't affect anything.
No.
You don't have to have round numbers when you're completing the square or solving it or anything. I divide both sides by 2. It turns that into 5 and a 16th. Take the square root of both sides, add 3/4, and I got my 2 answers.
There we go.
All right. What else? We got just a few minutes here. What else besides completing the square? You want to work on some factoring where you have a number as the first thing?
Yeah, there's actually 2 problems.
Uh-huh.
The last 2 problems on my review packet.
Okay, good.
That I have not been able to complete.
Let's do them.
So, all right, so we've got 8x squared minus 10x plus 3 equals 0.
Okay.
And we got to factor that. It says factor and solve using the zero product property.
Right. Zero product property. The whole reason we factor these is because I want to turn it into 2 things being multiplied together.
Right.
Once I have 2 things multiplied together equaling 0, I apply that zero product rule, and I can then set each of these things to 0 to solve it. But first of all, I got to turn in this quadratic, which is the sum or difference of 3 things. I got to turn it into the product of 2 things. Well, this is a little bit more trial and error. How should we start this factoring?
We could, I guess, just start off with 4x and 2x.
I'm always inclined to start with the 2 closest factors, as opposed to 8x and x. Okay. Just because I would bet anything that the solution is 4x and 2x, not 8x and x. They tend to give you these problems, and they make the answers be the factors that are closest together. What are my signs? Which is the next.
They're both going to be negative.
Okay. And now there's not much. It's either 3 and 1 or 1 and 3. Let's try 3 and 1. Does that work?
Let's see. 8x squared plus 4x.
Hold on. Let's back up a moment.
Yep.
We don't need to check this term. When we
Oh yeah, because we
factored it,
already
we
know.
made sure that those two things multiply together to 8x squared. We also don't need to check this term because we made sure that these signs and numbers multiplied to plus 3. So I only need to check one thing, the middle term.
Well,
And you get the middle term, this minus 10x, you get it by multiplying the two inside and the two outside together and adding them together. So this minus 3 times 2x is minus 6x. This 4x times minus 1 is minus 4x. Add those together, minus 10x. We got lucky. Our first try, we hit it right on the nose.
awesome.
Now, if I also had a choice, I could have put the 1 there and the 3 there. And you can see that does not work. That gives you negative 14x in the middle.
That's not what we're looking for.
So I would then try that, and that works. Now solve it. In other words, we factored it properly. How do we solve it?
You're going to just set each one of the, each part of the problem, and you're going to set it equal to 0.
Okay.
So we're going to have two solutions.
Okay.
And they're going to be 3/4 and 1/2.
Good. Now, the zero product rule doesn't say both things have to be 0. It merely says one of them has to be 0. Well, with most quadratics, both solutions are going to be valid. In other words, x can be equal to 3/4 and x can be equal to 1/2. Both of those work. If we plug it back into the original quadratic, we would find both of them worked. Sometimes, if you have things like radicals in your equation or absolute values in your equation or logarithms in your equation, you can frequently come up with one of the solutions and it doesn't work, and you have to throw it out. Those are called extraneous solutions. But you don't typically get extraneous solutions when you're dealing with just quadratics, normal-looking quadratics like this. All right.
Gotcha. Yeah, that one looked like a lot harder than when we actually ended up
Let's
factoring.
do your last one here, if you don't mind. We'll just take a couple minutes extra. Make sure you can do it.
All right. We've got a 6x squared plus 9x minus 15 equals 0.
So first thing I can do here.
You can put it 3x and 2x.
I can factor out a 3, right? In other words, whenever you're looking at a quadratic, always simplify it as small as you can get it. And I can take a greatest common factor of 3 out, leaving this, which is going to be much easier to factor, merely because there won't be as many choices. Okay?
Yeah, I completely forgot that you could pull out a greatest common factor.
That's always the first step when you're factoring a quadratic, is to see if you can pull out a greatest common factor before you attempt to factor it normally. Okay, so now the only part we're dealing with is this middle part, which makes things simpler because there's not any choices. It has to be 2x and x, and it has to be 5 and 1. What's next?
Oh, yeah, that made it a lot simpler.
Yeah, what's the next step, though? What's step 2 in factoring? My step 2?
Figuring out the signs.
Okay, what are they?
There's gonna be one positive and one negative.
Right. So I know they have to be opposite, but that is not the same thing as if I have a minus sign here and a plus sign over there. It's only the same if these coefficients of x are the same. Well, they're not here. One of them's a 2, one of them's a 1. So to handle that, I do it like this. Okay. Now, I don't have to try a whole lot of things. There's only 2 factors of 5, right?
Yeah.
Let's start with 5 and 1, just randomly. I'm not even looking to see whether that works. Gosh, every time I do that, it always works, and I don't want that. I don't want it to work on the first time. Let's try 1 and 5.
All right.
What middle term would that produce?
That would produce 1x and negative 10x.
Okay, so that would produce a minus 9x as a middle term.
That's not what we need. We need positive.
More importantly, that's not only wrong, but it tells me that there's no point in me trying a 1 down there and a 5 down there, because that's going to produce the same number, just the different sign.
Right.
So that, knowing that that solution produces a minus 9 here, tells me that the only possible answer is to switch it this way. Put the 5 here and the 1 there. And that does produce plus 3x in the middle.
Perfect.
Now, what do we do about this 3 over here? Divide both sides of the equation by 3, gets rid of it.
Yep.
Because 0 divided by 3 is still 0. And then apply the 0 product rule to solve, so x is equal to minus 5 halves, or x is equal to plus 1.
Awesome.
Okay. Casey, that take care of you for tonight?
That is perfect.
Okay.
Thank you.
You're welcome. Good luck to you. I'll talk to you next time.
All right. Thank you. See you, David.
Bye-bye.